The purpose of this video is doing a concept check on all these topics. So independence, mutually exclusive, discrete random variable, continuous random variable, normal distribution, normal standardization, and standard normal distribution. Let's read the problem. So if two events are independent, then these two events are mutually exclusive. Is this true or false? So independent means mutually exclusive. Is this true or false? The answer is number one is false. Independence and mutually exclusive, they are two different things. There is no way to pull them together. So that also answer number two. If two events are mutually exclusive, then these two events are independent. True or false? That is false. There is no way to pull these two things together. They are not related at all. Just like apple and orange. All right. Number three, a discrete random variable can take on any of the countless number of values. That is already a mistake. So this must be a false. Because for discrete random variable, so let's say you roll two fair dice and you want to let the x be the sum of the two face values. So x can be the smallest sum is 1 plus 1, right? So that is 2, it can be 3. The biggest sum is 12. So x can take on a finite number of value, countable number of outcomes. So if you count this list, there are 11 different outcomes. So the correct answer is should be countable number of outcomes, not countless. And then number four, a continuous random variable can take on only a finite. No, continuous random variable can take on a countless or infinite number of outcomes. Number five, for probability distribution of a discrete random variable, the sum of all the assigned probability does not have to be 1. No, that is false. So number five is false. So let's say I give you a grade distribution A, B, C, D, and F. So let's say A is 30%, B is 30%, C is also 30%, and then this is a 5%, this is a 5%. So 30% people got an A, 30% of people got B, 30% C, and then the rest is 5% and 5%. The sum must be equals to 100%. If I change the 5 to a 15, that makes no sense. So for discrete random variable x, the sum of all the probabilities must be equals to 1 or 100%. So that's why number five is false. What is the meaning of expected value? So expected value is a long-term average. So if you keep doing this statistical experiment, what is the result that you will get in the long run? So you repeat an experiment infinitely many times. What result do you get in the long run? That is expected value. Number seven, in a binomial experiment, the result of each trial has more than 2 outcomes. Number seven is false. For binomial, it's like flipping a coin. You either get one side or the other side. So there are 2 outcomes only, which is either a success or a failure. Number 8, the empirical rule, which is in the picture, applies to normal distribution and any other distribution. Is this true or false? That is absolutely false. So this empirical rule is for normal distribution only. All right, for normal distribution only. So number 8 is false. And then number 9, if a distribution is standard normal, the mean is equals to 1. No, the mean is not equal to 1. The mean is equals to 0. For number 9, standard normal is mean equals to 0 and standard deviation is equals to 1. If the standard deviation is equals to 0, the bell disappears immediately, because standard deviation equals to 0 means every number is exactly the same. If the mean is equals to 1, standard deviation is equal to 0, that means you only have one kind of data. In a list of data, every single number is 1. So the average is 1. There is no standard deviation because every single data is the same. Number 10, state the formula of normal standardization. All right, when the sample size is not given, so that is z equals to x minus mu divided by n. And then number 11, when the sample size is given, so that is z equals to x bar minus mu divided by sigma over square root of n. What is the minimum sample size? So n is greater than or equal to 30 according to central limit theorem. All right, so that will be all in the concept chat. I see you in the next video.